What's up, guys? Today we're going to be testing out something really cool here. Basically what I've built is a test device. It's a waste oil inline heater. I want to see if the concept works before I go getting too crazy. So this is just something I slapped together last night. I want to show you how it works. Check that out. Not bad, not bad. Ooh, that sucker gets hot too. That was a nice little burst of heat. So basically the idea is, I'm going to connect the thermocouple up to this bad boy, and we are going to build an inline heater that can be calibrated fairly accurately by using this router speed controller that's been modified with a massive heat sink on the back connected to the triac inside, and a 500 watt halogen light bulb, which I did touch with my fingers. Unfortunately, when I threw this together, it's in such a way you can't get the light bulb out of there. So if it blows, I gotta tear this bad boy apart. This is epoxied together with porcelain and JB Weld for the dielectric purposes of the mounting, because I have a metal frame here. So I went ahead and painted it gray because I wanted to be able to see the temperature with the thermal gun. Man, that thing got hot from just that little burst. Can't imagine how hot that inner tube is. So this is going to be a pretty cool one. We're going to hook up my calibrated oil pump, and we're going to get some temperature readings, and I want to try to make a device that can produce oil at 300 degrees, right around 4 liters per hour, or about a gallon per hour. That's kind of like the right around the area I've been burning a lot of my waste oil burners at. So it'd be cool to see it at other operating parameters, obviously, but I want to see if this particular design can fit those specifications. Basically what we have here is a miniature heat exchange. You have an inside tube there that goes through this outer cowling that has an intake and a discharge. This discharge is a needle valve that will have a thermocouple lead in place of the needle valve stuck down inside of there, so we can get an exact discharge temperature. But man, is that freaking cool or what? Seems like just touching it a little bit though. Uh-oh, I'm loose. I'm gonna have to adjust my springs. I forgot I have these screws tightened. Didn't have it set up right. But at any rate, we're gonna check this thing out. Still tweaking it around on the electrical side of it. Making a high temperature contact is not gonna be easy. We're gonna see how this goes. It's probably gonna burn itself up, and eventually what I'm gonna do is most likely just go out and buy a halogen lamp and use their setup and put this heat exchange in there, because building this mount was a real pain in the neck. Basically what this is going to do is preheat the waste oil, and I'm going to do it using a 500 watt halogen light bulb. So this ought to be a pretty cool build. I'm going to control this light bulb using a router speed controller. So we're going to be able to get pretty good temperature control. I figured this electric one would be a lot better than a propane powered one. I don't know how much buildup is going to get inside of this thing, but it can always be taken apart. So essentially what we're going to do is hook this bad boy up. So let's get to it. I just want to be able to pass oil through it and warm it up in the process. So definitely too cool. Do a quick experiment here with this inline heater I built. It uses a 500 watt halogen light bulb inside of a miniature copper heat exchange. I'm going to be using this router speed controller to adjust the power, and in addition to that, we're going to be checking the temperature of the discharge. Now my goal here is to set this thing up to put out 300 degree oil at 4 liters an hour. However, I just realized I'm probably about to melt this bowl. I'm going to have to get something a little better than that. I'm going to test it on low first just to see how hot it'll get the oil. Okay, so I'm going to turn the oil on to a flow that I'm accustomed to seeing the siphon pull this at. And we're going to observe the temperature. That's a pretty common looking flow there. Okay, so that's pretty slow drizzle. I'm going to kick it up to about that. And as you can see, it's showing a temperature of 72 degrees on the thermocouple, which is mounted inside that T. Let's turn this unit on the lowest setting. Check that out. That is too cool. That is 82 watts of heating power, which may not sound like much to you, but bear in mind, I own a 25 watt soldering iron. So there's a substantial amount of heat going to be cranked into this thing. And you can see the temperature of the discharge oil is already going up, which is pretty freaking cool. I might want to turn that up just a little bit. I don't know that that's a good enough flow rate. I'm going to tweak it just a little bit more. Temperature is rising rapidly. I only need 300 degrees. This is a very unstable rig, thrown together in a great hurry just to test the concept. Now, if this fills up to 500 milliliters in 7 minutes, we know we're right at about 4 liters per hour, which is the target for the burner I'm working on. Oh, that is too cool. Okay, that's fancy and all, but it's just not enough. It's actually very hot to the touch. Very hot. Let's move on. Showing that oil discharge at 126. Man, that's just too cool. Wonder how hot those terminal leads are getting. Not too bad. I'm worried about these terminals. Definitely some warm oil coming out of that. $80 watts of heating power. Now the cool thing about this little device is I'm also going to be using it to preheat water on a steam cleaner I'm going to build. So this should be able to let us calibrate fairly closely. And mind you, this may be too fast of a flow rate. I still haven't calibrated this pump. I'm going to build a dial so I know what the flow rate is at a particular setting. I'm going to put like a round disc up here. If we hit 500 at the 7 minute mark, we're right around that area. Problem is, we are at the 1 minute and 35 second mark. temperature is still rising. This thing's probably too hot to the touch. Dude, it's very hot. Getting very hot. Working very good. We have a lot of power to work with. We are on the lowest setting, people. It won't go down any more than this. Not heating a substantial amount. Still, it's very warm, very, very warm to the touch, and would be very conducive to the waste oil burning process. I didn't spend a dime on this, by the way. This is all stuff I had in the garage already. A little worried about my electrode setup. It wasn't cooking like that earlier. The glass is just touching the inner coil. I regret not painting that copper tube to reduce the reflection rate. I would imagine a lot of the infrared radiation is getting reflected from that shiny copper, but you never know. Steadily getting hotter. I don't know if I can get a... We're basically 72 degrees on the input oil. Seems to be stabilizing right around 154 degrees. Man, that is just too neat. I was trying to think of a way I could do this, and it just dawned on me, man, a light bulb would be awesome for this. And I have two 500 watt halogen bulbs doing nothing. Coming up on 3 minutes, and we're halfway there. So you know what, guys? We might be right around 4 liters per minute here. With this needle valve oriented just as we see here. I don't know how many turns out that is. I'm afraid to touch it. Oh, okay. So that right there is looking like real close to 4 liters per minute. We're up to 160 degrees on that discharge temperature. Now, I tried to build this in a high flow configuration so that it didn't inhibit the siphon. So it should be able to work with a siphon just fine without inhibiting flow big time. I mean, there's a little bit of flow resistance, but we're at about 4 minutes. Coming up on 300 milliliter. And it seems to be stabilizing here. And it is very, very hot to the touch, like screaming hot to the touch. I hope the JB weld holds on my terminals. It could fail at any moment. Like I said, guys, this is just a test apparatus to determine the plausibility of the concept. If it wasn't able to produce good temperatures, I wasn't going to bother, but this is totally worth doing, you know, an extensive build. This alone took me all night. This cobbled together crap took me about 6 man hours. Well, you got to find all the pieces. You got to think about how you're going to do it. You know, there was a lot of thought. Took a few breaks. I need my breaks, man. I use them wisely. So, I think we've seen enough at this 150 degree crap. I'm going to turn this thing up to 100 watts and let's observe the temperature output at that rate. It's obviously going to get brighter, of course. We're going to leave it right there. It's probably just going to jump all over. Definitely looking brighter. Man, that is just so freaking cool. It's not often I tickle myself. But the coolest thing about this is going to work so great on my steam degreaser tool that I'm building. If you guys have seen any of my steam tools or my propane torch steam coil, this thing is going to be so awesome for a preheater. I'll be able to preheat the water to 200 degrees barely put any propane flame on it, and it's going to blast steam. Okay, 100 watts is doing 165 degrees, but it may get hotter than that. We haven't stabilized out. This is definitely a hot bucket of oil. It's like getting ready to... Okay, we're coming up on 7 minutes here, and we're at 400 milliliters. There's 7 minutes right there, guys. So it appears we know next time to start the test and leave it at this and test. I did some jumbling around with the gauge, fiddling. So we are real close to a 4 liter per hour burn. It looks like I need to turn it up just a hair to reach that mark. So we're gonna say, we'll try that. We'll try 5 degrees. That's probably a little more than 5 degrees, but we're gonna try 5 degrees off. Temperature is gonna be altered now that we changed the flow rate. I went ahead and soldered these ends off because a leak would mean catastrophe. It would totally destroy the rig. So those, I've soldered those off anyway. We've talked about this. I am a little worried about that bad boy leaking on me, but so far so good. It's not under a lot of pressure. However, I don't know I'd trust this on a pressurized system. Okay. We're at 8 minutes. We're coming up on the 500 milliliters. I'm gonna shoot. How should I do this? Tell you what I'm gonna do. I'm gonna turn it off. I'm gonna shut the oil flow down. And I'm gonna move in a pot that can handle the heat. And we're going to see what this thing can do. We're going to go back to the 5 degrees location, which should give us right about the operating range we're going to be running at. Turn it on the triac. Sometimes you got to jump it. Doesn't want to just fire right up on low. Let's do 150 screaming watts here and just get this show on the road, guys. Okay, that's pretty close. Not super bright. Then again, I've got some serious lighting going on in this place. I actually turned 2 of them off for you. I wanted to get the effect of the illumination to show. I don't see any bubbling coming out, but I am starting to see a little bit of bubbles actually. I take that back. We risk roasting the oil in there. It's going to take some time to heat up too. Terminal area is fairly decent. We're kind of stuck here. I'm getting some boiling inside the unit, I think, guys. Definitely really hot. Yep, it's boiling inside the unit. It shouldn't be. It's 305 degree flash point. But something's obviously going on. I could just be out of oil. It might be about running low. I don't know how much was in this thing. I'm just fly by night right now. Something's happening. We're about 147 watts. Some kind of odd gurgling, which is indicating to me that that interior tube is getting so hot that we're getting some gaseous oil. Now, if I ever did do a really nice build on one of these, I would make it where you can take it apart and clean it. That's important. It smells like oil. It's not, you know, extravagantly hot though or nothing. I'm inclined to turn it up. I don't know what all this gargling business is about. It's definitely super hot to the touch. Okay, we're going 200 watts, fellas. I got stuff to do today. I ain't got time to be hanging around. This is gonna get a little wild here. This is where things could go bad. It's definitely bright, and it definitely appears to be boiling oil or something. You're certainly getting a temperature increase. This is good here. This is really good. What do you think, guys? Is there some boiling going on in there? Just because that probe's at 190 don't mean we're not at 300 degrees, right where the light bulb's at. Something weird's going on. Look at that. The surface area may be too small for the amount of heat we're injecting into this area, which is causing localized boiling, which is surely going to carburize the unit up. Concerned about that. I can feel the heat coming off of this little sucker. So as far as using it for an inline heater for a preheat on my steam cleaner, this is definitely going to do the job very well. So with 200 watts, we have preheated our oil to 194 degrees Fahrenheit, which as a result I appear to be observing some boiling going on inside of there. It's definitely boiling, guys, and I'm going to prove it. I'm going to shut it off. The system is now off. We are at 199 degrees on the thermocouple probe, validated by the infrared gun, and we should see that dribbling stop here in a minute. It should cool off. It appears it may have. There could also be some debris clogging up in there. Still fairly hot. Temperature going down very quickly. And as you can see, the erratic behavior has ceased. So there may be some gas that was boiled out still trapped in there. Maybe some dissolved gases, some dissolved gasoline. That's another thing, guys. This oil has gasoline in it. Some of it did, and I don't remember which batch. So we may have just boiled off some gasoline in there. That's another possibility we really need to remember. So from what I can tell, we were in fact observing boiling. But as I said, it could just be from the gasoline. Completely cool to the touch. And we are going to end this experiment, which I would deem an extreme success. It's been a while since I could say that. Things worked out very well, fellas. We were able to heat that oil up. We were at 200 watts. We got it up to 200 degrees, ironically, at the flow rate we were going at. Pretty strange correlation there, but we can go up to 500 watts. However, I do not believe this rig is robust enough to handle that. These terminals will die if I do that. But don't put me past it. I'll turn that sucker up to 600 watts. I'm going to shut this off now. One of the things I need to do, I just wanted to show you guys what I'm working on here because it's so freaking cool. that I thought I'd give you a little preview. I'm going to calibrate this pump and figure out certain flow rates. We'll just use 60 psi as a benchmark. 60 psi is a good tank pressure. It gives you lots of flow without too much pump activity. The reservoir for that test, I gotta be careful turning this. See what we're at there, and that used hardly no air for that test to pump that much oil. And now I gotta tell you, man, I'm liking this thing. However, I'm seeing a problem. The surface area of the heater is too small. Too much energy is being introduced into the system in too small of an area. Now, when I put this together, I thought to myself, you need to put heating fins on that interior tube. And I even got the piece of metal out to do it with. But I talked myself out of it. I decided to run the test to see if it would be okay without them. Now I'm regretting it, because it appears that indeed, if you go to build one of these, you definitely want to increase the surface area of that interior heating element, that inner copper tube. Definitely going to want to put some cooling fins on that. I regret not doing it, but I didn't want to overbuild it. You know, there could have been a chance that this wasn't enough heat to do the job, and then here I've wasted all this time. So the concept was a success, a screaming success. I'm definitely liking this. This thing's going to have a couple of uses for me, and will definitely improve any siphon nozzle that I build. This thing will make anything work. You heat oil up at 300 degrees and it'll burn in a bucket. So it's going to make things easier. Definitely an easy build. This is something just about anyone can do. If you were to pay for all these parts, probably looking at about $45 worth of stuff there, maybe. The thermocouple was $14, you know. The fittings are $5 a piece. Some wire and springs and all that goodness, but it was free for me.